During icebreakers, I used to say that the coolest facts about me are that I have type 1 diabetes and want to become an astronaut. But honestly, I've always wondered how I could do both because going to space requires incredible physical abilities and endurance. Type 1 diabetes is a cell-mediated immune response. The immune system possesses T lymphocytes that attack foreign invaders and antigens, a substance that causes an immune response. T cells can also react to our own antigens, so there's a mechanism in place called self-tolerance. Environmental factors can influence the expression of self-tolerance genes, though, and can switch them off. Our bodies are required to be efficient, and having T cells that destroy parts of ourselves counteracts that idea. One critical group of genes located on chromosome 6, called the human leukocyte antigen, or HLA system, code for the major histocompatibility complex, which serves as an antigen presentation pathway in cells. The MHC, or class 2 specifically, has two major functions. 1, recognizing foreign molecules, and 2, maintaining self-tolerance. When certain environmental triggers offset susceptibility genes like HLA-DR3 and HLA-DR4, autoimmune diseases like T1D can occur because it can result in an inappropriate immune response. In type 1 diabetics, there is a genetic abnormality that switches off self-tolerance and targets insulin-producing beta cells in the pancreas. With a lack of that process, T lymphocytes can gang up and destroy a good majority of beta cells. Without beta cells, the production of insulin diminishes and leads to an influx of glucose in the bloodstream. Uncontrolled hyperglycemia, or continuous high blood glucose levels, or untreated hypoglycemia, persistent low blood glucose levels, can produce further complications including comas, vision loss, heart diseases, kidney failure, or strokes. Hyperglycemia is treated with insulin, while hypoglycemia is treated with glucagon, or fast-acting sugars. So what's the correlation with space? Well, space may accelerate some of these complications. Let's simulate it. This is me, astronaut Shreeya, and at T-minus 2 seconds, I am preparing for liftoff. With 4 million pounds of propellant being expelled in 8 minutes, my body will be accelerating at 3 times the acceleration due to the force of gravity. If at any point in the flight I experience a hyperglycemic or hypoglycemic attack, it would be virtually impossible to administer insulin or glucagon. Fast forward, and I'm in a state of microgravity. Massively influenced, the heart becomes smaller and requires less glucose to function, but more exercise. Prolonged periods of hostile conditions, strain, exercise requirements, and dietary restrictions also elevate stress hormonal levels and lead to a suppression of my immune system, which can lead to enhanced vulnerability to microbial infections or allergies. And not to mention the radiation. Cosmic radiation has the potential to alter genes and influence cell aging mechanisms. And let's be honest, my genes on chromosome 6 have been influenced enough. Putting it all together, it can be concluded that maybe type 1 diabetics can't go to space just yet. But there are T1Ds training for liftoff already, and with new technology, advancements, and research, maybe you all will be seeing me on Mars. My name is Shreeya Patel, and you just learned about the genetics of diabetes and diabetics in space. Thanks for watching.